Yes, he's recording. All right, so we're going to do another one where we're changing a recurring decimal to a fraction. Now, we did one just the other day, but we did it very quickly as we were leaving, and there was a lot of questions about it. That's the one we did. Cool? And Caitlin doesn't like it, sorry. Caitlin, don't throw stuff. Caitlin doesn't like it, so we're going to go through another one, and you'll see that it's not actually that bad. Stop sending me messages. All right. Now, the whole point is, if we're writing 0.4 as a fraction, you realise that the 4 is repeating forever, correct? Okay, so that's, you know what the dot means. That's a basic but very important point. So this one, we've got 1.329. So what's repeating here? Cool, so we've got 1.32929292929, okay? Everyone happy with that? All right, so what we're going to do is, we did this last time, but I'll just explain it again. We're going to define a variable, okay? Anyone know why we're going to do it? Yeah. Yeah. Basically, we want to get rid of that recurring bit. The recurring bit is a pain. It's very difficult to deal with, yeah? So we want to get rid of it. And there is a couple of ways to get rid of it, but this is by far the most efficient and the most quick, okay? So what we're going to say is go, okay, well, what we'll do is we'll go let n, and we just use n because n is just number. We could use y, we could use x, it doesn't matter. Let n equal 1.329 with the two repeaters, okay? You happy? Yeah. Okay. Now, last time when we did this, we had it equaling 0.4, and yet we times it by 10. Why did we times it by 10? Yeah, so basically what everything other than the recurring bit over the other on the left-hand side of the decimal, yeah? And that way when we subtracted it, we were able to just cancel out the recurring bit. And I'll refer to it as the recurring bit because that's the official name now. We want to get rid of the recurring bit. Cool? So, going back to that. So, our recurring bit is the 29, correct? Yeah. So, we need everything other than the 29. Well, we actually need... So, I'm actually going to get rid of those recurring bits above and just put... So you know what it looks like, kind of. Does that make sense? Yeah. So now, we did times 10. So what do you reckon we'll times this by? Do you reckon 10 again, or? No, 1,000. Yeah, because if we did 10, it would be... Well, if I just run 3 to 9 to 9 to 9, dot, 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 dot. Okay, and I'll just change colours for a sec. I'll just go to red. And if I times it by 10, I'd just have that. Yeah. Wouldn't I? Sorry? Yeah. The problem is if we try and take that away from that, it's not going to work. It's not going to cancel out, is it? Let's put 10n there because that's what it looks like. So what do you want to do now? Okay, so let's go 1,000n equals what? Beautiful. That looks awesome. Does that help us? Well, it does. But on the last one, I want you to pay attention to this. On the last one, we went, right, well, we can do the 10n minus the n, and that will cancel out the two decimals, the repeating decimals, yeah? Because you can see that beyond the decimal point, they're all exactly the same. So you minus one from the other, and you're going to cancel them out. Is that cool? Okay, but on this next one, looks slightly different. Can we do the 1,000 minus the n? No. Why not? Well, I've just got n, and it's worth 1.32, blah, 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 blah. Okay? But if I tried to do this one minus that one, what's the first... Well, where does the 29 start? It starts right after the decimal point, right? Yeah. Here... If we tried to subtract it, it wouldn't cancel it out. They're not the same. Everything everything on the right of the decimal point has to be the same. Otherwise, when we subtract them, it's not going to cancel out. Does that make sense? Yeah. This one's not the same. It's got that bloody 3. Can you see that they're not, like they won't cancel out? Yeah. If we ignore everything on the left of the decimal point, those two would not cancel out. Does that make sense? But, however, have a look at the 10 times. Everything on the right-hand side of that decimal point is the same. Does that make sense? Yeah, everyone happy with that? So what we've done, the whole reason we're multiplying it by 10 or by 1,000 or by 100 or by 1,000,000 is we want everything on the right-hand side of the decimal point to be the same. Yeah, we're going to do 1,000 minus 10. Now, just as a question, could we have done 100 times n? What would 100 times n have looked like? Yeah, what would the right-hand side have looked like? Yeah, it would have been 9292, and you couldn't do that. They have to be the same, so they cancel out. Cool? So that's why we're using 1,000 and why we can use 10. Cool? On the other one, and you'll find, eventually you'll notice a pattern. When you see how many decimals are repeating, you'll be able to tell how much you have to multiply things by and what position they are. There is actually a pattern. I'm not going to tell you what it is. I'm going to let you look at it and do a few of them, and then all of a sudden you go, that's what he's talking about. Okay, it will appear. Okay, if it doesn't, don't stress, because you just use this method and it works all the time. Okay, so now we're going to do those two. We're going to do 1,000 n minus 10 n. Now, we just made those things up realistically, or we calculated them, but you could have done 1,000,000 and 10,000 if that's what you needed to do. Okay, but we're just going to subtract those. So what we've got is 1329.29 repeater, and I'll just write it like that, minus 13.29 repeater. Does that make sense? Everything on the right-hand side of both of those terms is 29 repeater. So we've now got a wonderful thing that we can just do that, and they are going to cancel each other out. Cool? That's the whole point. That's what we're trying to do. If when you do this, if you're doing these and it doesn't happen, you know you've got to go back and revisit this. Sorry, what do you mean would it change on the 1329? Yeah, well, we're now going to have 1316. Yeah, but this is now 990n. So we've taken 10n off the 1,000n. So we're left with 990 n's equals 1316. Does that make sense? 29 minus 13. Yeah? Decimal point's not very visible. Well, this one says 990n actually means 990 times n. Cool? That's what it means. So how do we get rid of, if I had 2 times something, how do I get back to something? I divide it by what? Yeah, so in this case, this is 990 times n. How do I get rid of it? Okay, it's called inverse operation. So we do the opposite to what it is. This is 990 times n. So we divide both sides by 990. Those cancel out. You end up with n equals 1316 over 990. Cool? Now, that can be simplified. You'll notice that they're both even numbers, so I'm going to leave it to you to simplify. It may be divisible by more than 2. You may be able to do it by 4 or 8 or 16, but it's definitely divisible by 2. So have a go, see if you get it. Thanks for coming. Catch you later.